Today I'm going to be talking to you about Dremio's query acceleration technology. And I think hopefully by now you know it's basically called Reflections. All right, so as part of the agenda today, it's going to be a technical talk. And I'm going to be showing you actually a lot of demos in the UI as we go through this. But we're going to start with basically what are reflections and how they're kind of different from materialized views. Then we're going to go into basically query planning, which is about matching reflections into user queries. And then finally, reflection management, which is basically about keeping reflections up to date. All right, so let's just get into it. So what are reflections? Now, I like to think of reflections in terms of the use cases that they can solve, right? So when you have a complex semantic layer and you're running queries where you're passing through, tens to hundreds of views or tens of hundreds of joins, querying from billions of records of data, there's no way that's going to perform, well against for dashboard queries. And so what you have to do is basically pre-compute this data, right? Do it up front once so that your dashboard queries can be, potentially a sub-second, right, or in the seconds. So a key use case for reflections is for BI, right? Now another use case is when, you're querying, say, like millions of like CSV, JSON files, right? Which is really not ideal for, analytical querying. And so with reflections, you can basically optimize the physical storage by turning by basically creating materialization that's in, say, Parquet data file format. And furthermore, you can partition and cluster the data so that you basically lay out the physical file so it's ideal for query access, so that you achieve like the maximum, say, partition and file pruning, right? And then finally, another use case is when, you're querying, say, Oracle data joined to like data out in S3. And that could be an expensive, like, federated join. And so you want to materialize that so you don't do that every single time, when the dashboard runs. All right. So these are all like common use cases for reflections. Now, when talking about reflections, oftentimes people will say, oh, reflections are materialized views. But reflections are really much more than just a materialized view. I like to think of reflections as almost like a relational cache, right? And the reason why I describe it that way is because reflections, when we match reflections into user queries, we think of these as basically query trees, right? And so you can imagine that, like, when a user runs a SQL statement, right, we turn that into a query tree, right? And basically with reflections, we're basically matching subtrees with subtrees of the user query with subtrees of the reflection, right? And so we're basically doing all these like query rewrites. And so the key point here is that from a user's point of view, you don't have to reference the reflection. They don't have to know anything about these reflections. The user could query against the view that the reflection is materialized against, or the user could just directly run the SQL inside the view, and our planner will match that query tree against the query tree of the reflection. So let me show you an example of that in the UI. All right, so let's just quickly create a reflection. So here I have a view that's based on the TPCDS query number 3. And so this is a very straightforward SQL statement. I mean, like, this is a fact table joined to 2 dimension tables on, this join key and that join key, where we're grouping by these dimensions and then summing by this particular measure. So this is a really basic query. And then let's go ahead and create a reflection. So I'll turn that on here. All right, so it's materialized. Let's go ahead and then let's run a query against this reflection. So, all right. And then if we click on the query profile, we'll see that it was indeed accelerated. All right. So this is a very straightforward case where I directly queried the view that the reflection was based on. So of course the planner chose to use it, right? But I could also directly run the SQL that the reflection is based on. So let's take that whole SQL statement and directly run it. And here I'm not referencing the view at all, right? And so we run it and look at the query profile. We'll see that the reflection was still matched into the user query, right? And so this is where I talked about where we take the query tree of the user query and are able to match that with the query tree of the reflection. And so, you know, if you look at the profile details and look at this tab right here, our planning tab, I'm not going to go into this in super detail, but basically this was the query tree of the reflection. I mean, of the user query, and you can see how we ended up rewriting that and to use just a simple scan on the reflection, right? All right, let's go back to slides. Cool. All right, so what is it that you want to materialize in a reflection, right? So you basically want to materialize expensive operations such as scans on, you know, slow file formats, filters, projects, joins, and aggregations. But basically the idea is that you want to take all this stuff, all these operations out of query time and basically compute it once and reuse it. Now, as far as what Dremio Reflections support, there's very, very few limitations as far as what can be inside the SQL constructs, right? So we support any join type, any aggregation type, you know, including nested aggregates such as group bys on top of group bys, window functions, set operations, time travel queries, UDFs, user-defined functions, and more recently, row column access control policies. And what that means is, you know, you can have like security policies defined on a table, right? So that like you can restrict access to different roles or different users. And what we can do is, as part of when we materialize a reflection that contains this table, we'll actually dynamically pull that filter out of the materialization. And then when the user queries something that could use this reflection, we dynamically reapply this filter at query time. And so now what you've achieved is that, like, you know, the same materialization could be used by different users, different roles, while still enforcing your access control policies. Now, as far as like limitations, you know, stuff that we wouldn't support is if you have something that's like non-deterministic in your SQL. So for example, if you have a random function in there, right, that's something that we can't materialize, right? And it doesn't make sense. So behind the scenes, reflections, the materialization storage table is an Apache Iceberg table, right? And we also use a nested catalog, you know, for maintaining the location of the tables. All right. So let's talk about the second agenda item, which is basically query planning with reflections. And really, this is about how we match a reflection into a user query. So you can imagine that planning queries is a complicated process, right? And our planner goes through multiple phases. And probably the most complicated phase is called logical planning. And in logical planning is where we do the reflection matching. So when I talk about reflection matching, I like to break it up in basically 3 steps, right? So the first step is you need to figure out which reflections are the ones that you can consider for this query, right? And in general, these are going to be reflections that have overlapping tables or views with the user query, right? Once we have that initial list of candidates, right, then we have to go through the much more expensive process of trying to match the reflection into the user query, right? And like, you know, there's one of the first things we'll do is we'll for example, normalize the query trees. And so, for example, you know, we will like do something like we'll destroy join orders, right? So, for example, if you're joining like you know 10 tables, right? We'll destroy the join orders so that we can match a subset of those joins against the reflection, right? Another thing that we'll do to match queries is we'll rewrite the original user query into alternative forms so that we can say match reflect to this into this new form, right? And you know, one example is called the ag join user query alternative. And actually, I'm gonna demo and talk about this one on the next slide. And this is how we match the aggregate reflections, right? So once you do this, then we try to actually match and unify the reflections into the user query. And what that means is like now we're looking at the query trees of the reflection bottom up and trying to match that into the user query. And one of the important steps here is called unification. So the idea here is that like if your reflection contains more data than what your user query has, right? What your user query needs, right? Then you basically have to add an additional filter on top of the materialization storage table before you can put that into the user query, right? And so that's an example of a simple unification that rule that we'll do. So once you have all that, then you have a bunch of replacement plans, right? Where like you've got reflections that could be used in different parts of the original query, user query tree with different alternative forms. So all that is then given to our cost-based optimizer. And here, we're basically searching through all these different plans to try to find the best one, right? And basically we use things, we'll have a cost model and then we'll have statistics, right? On like, for example, the row counts of each table, of the reflection versus the base table. And then we'll also use things like partition stats, right? To basically estimate, what is the row count of this table after filtering, of course, right? So filter scans. And then we'll basically, in the end, produce the best plan, right? And remember, the best plan can mix and match reflections, right, in different parts of the query trees to find one that has the lowest cost at the top of the plan. All right, so let's talk about an example of matching an aggregate reflection into a user's query. And now I will also demo this after this. So let's imagine we have a reflection on top of a fact table sales, right? So here, I've got fact table sales, and I'm basically summing a measure and then grouping by the product ID. Now here, I come in with a user query that joins, that basically takes the sales table and joins with the product table, obviously on the product ID key, right? And then you sum by the measure and then group by the product name. So if you look at this on face value, this user query doesn't really look like this reflection, right? But what you notice is that this aggregate operator can actually be split and decomposed below this join, right? And so when you do that, then you basically now need to aggregate by the join key, in this case, which is product ID. And so once you do that and you rewrite this query, now this side of the query of the join now looks a lot like the reflection right here, right? And so then our planner is able to replace this put this reflection into this left side of the join, right? So basically this turns into a scan on the materialization storage table. Optionally, you can also do this on the right side of the join too, which is shown here. All right, so let's show how this looks like in the UI. All right, so let's go back to my view again. And what I'll do here is I'm going to go turn off that first reflection I created because I want this query to match using what I just had described. All right. So if we look at this view, right? Look at the SQL statement. Basically, our fact table here is store sales, right? And we're joining to these two dimensions on these two keys. Okay, these two join keys. And then what we're doing is then summing, discount amount. So let's go ahead and create that aggregate reflection on top of store sales. Okay, so here's store sales. Go in there, go to reflections. Let's create an aggregate reflection. Let me go clear all this stuff out. So we got date key, item key, and then there was discount amount. All right. Okay, now it's materialized. Let's go back to the user query. I'll just directly run the view. Okay, and then we'll check the query plan. And now we see that the aggregate reflection, right, was matched into the user query, right? So this is, you can imagine it was a totally different, query. Like we pushed the aggregate below the join, right, and then put the material, then we put the reflection, underneath the join. And all this that I just described, all this rewrite logic, these user query alternatives, these replacement plans, they can all be seen in the acceleration profile, right? So this is all this, once you turn on verbose profile, like this information is basically logged here, right? We talk about considered, matched, chosen, and then, for example, the replacement plan that we generated was something called the ag join, alternative. So, okay. All right. So now I've talked to you a bit about matching. Let's go on to the final topic, which is reflection management. So reflection management is basically about like keeping your reflections up to date. But like I like to think about it as like trying to do it so that you do it such that you minimize your compute and storage costs, right? Because if you're always rebuilding your reflections every time the data changes, that can get expensive, right? So what are like the important cost considerations, right? So first and foremost, probably the most important thing is when you're refreshing your reflection, right? Basically like updating it with the latest data. Is it a full or incremental refresh, right? Obviously, full is going to be much more expensive than an incremental refresh. So, what you want to achieve is try to get incremental refreshes. Now, our system will pick the best method for you, but then there's certain conditions under which, okay, we can do an incremental refresh. And I'm going to talk about that on the next slide. The other thing to think about is, well, how long did a refresh take for a given workload management configuration, right? So when you're refreshing your reflections, you can set up workload management rules to target, a specific engine, which then has, a number of nodes and cores per node, and also like a concurrency level set on the engine. And those things will really determine like how long it takes or to refresh the reflection, or how many can you do in parallel, right? Other things are like, do you have engine replica scaling set up? So you can scale out engines, right? So that you can, if you're refreshing more concurrent reflections, will automatically scale up the engines for you. And then another important topic is, well, how much storage are you using for each materialization, right? So it's not uncommon for your materialization tables to be like, 100 gigabytes of disk space, right? But the thing to keep in mind, though, is that like it's not like a reflection is just 100 gigabytes, right? I mean, oftentimes you'll have 100 gigabyte reflection sitting on S3, right? But in the background, there's another reflection being built or materialized, with the latest data, right? So you often have like copies of the materialization storage table, right? And the planner will have to drain queries off of the previous materialization before it moves on to the new one, right? So you have copies of this, and there's ways to control like how many copies do you have. And then really another important aspect, obviously, is if the reflection is actually being used, right? So you do all this work to materialize it. You need to know, right, what is the impact of this reflection on user queries, right? And the impact is not just that it's being used because it's being it's accelerating queries, but there could be also a negative impact when, for example, there's too many reflections in your system and like you spend too much time considering matching and not using the reflection, right? So you need to know about that as well. All right. So how does a user see all this stuff, right? Actually, it's quite easy. So let me show you how it looks in the UI. So we have a nice reflection management UI where, okay, so here is the last reflection that I just built. It's the aggregate reflection that we just looked at together. So here we can see, for example, what is the current refresh status, right? So is it scheduled, or is it currently refreshing in the background, or is it maybe a manual refresh, something that like the system doesn't run automatically for you? Here we see when was the data last queried from the source tables, or basically last refreshing table, right? So this tells you kind of like what is the if your data is stale or not. Then you have like metrics about like, for example, record counts, the current footprint and total footprint. And remember, total footprint could be more than a current footprint when you have multiple copies of the reflection of the materialization storage table present. There's your last refresh, how long did it took, right? I mean, big reflections can take, 30 minutes. And then whether the refresh method that we automatically determined for you was full or incremental. And then reflections also have an expiration, right? So by default, I think it's like 3 hours. So, you can say that, okay, end user, your data will never be more than 3 hours stale, right? And that's what this guarantees. And then finally, you have all the different counts, right? So this tells you like how many times was the reflection actually used in a query versus how many times was it matched, right? So match produced replacement plans, which goes into logical planning. And so this gives you kind of insight into the effect on planning time and also usage. And then finally, this link right here, you can click into that, and then this is the actual materialization job, right? So this is the job that was used to to create the parquet files and then generate the iceberg table, or in case it was an incremental refresh, then what was done to incrementally refresh the reflection. One of the cool things is in the profile we also show the refresh method. So here there's a section called refresh decision, and tells you exactly whether we did a full or incremental. If we could have done incremental, what method did we use? Was it append only versus snapshot based? And so also if it was a reflection where we couldn't do incremental because it contained for example, like an outer join, right? Then we would tell you that here. All right. Okay, let's talk a bit about incremental refresh. So, ideally, you're refreshing your reflections incrementally, right? But whether we can do an incremental refresh versus a full depends on a couple of factors, right? So first thing is, what is your source data, right? Meaning, like, what is the data that's being put into the reflection, right? So if your source data is append only, as in like, you're ingesting, like, say, event log data, right? Then we support any source, meaning that it doesn't matter if it's JDBC, MongoDB, if it's an iceberg table, right? As long as it's basically your appending data, then we can support incremental refresh, right? Now, if there's updates and deletes, right, and the source tables are iceberg, right, then we support something called a partition-based refresh, right? And what that means is that we're able to look at the source data, diff the snapshot IDs, right, and then figure out what partitions and reflections have changed and basically rebuild those partitions, right? And this is how we can handle the updates and deletes. As far as like the SQL constructs that are allowed inside a reflection, we support, these aggregate functions, right? We support an unlimited number of inner joins, right? And then a single group by. And so, as I said before, we'll select the best method for you when the reflection is refreshed, right? As in, like, can it be incremental versus full? And if it's incremental, can we do append only or update and delete, right? Because these two have different materialization plans, right, associated to them. All right. Now, as far as a full refresh can be expensive, right? And so, the key thing about full refresh is you should only be triggering them when you need to, right? Such as when there's data changes. And so we have different refresh policies that we support. So, for example, like we have an interval-based refresh policy. So, for example, like every hour or every 30 minutes, right? And this is good for, like, if you're streaming data into a source table, right? And you're streaming data into a source table, and then you just want to update this table on a periodic basis, right? We also support schedule-based. So if now you're doing batch processing, right? So you're doing ETL loads nightly, right? Then every weekday at 5 a.m., kick off the reflection refresh, right? And then of course you can do it manually using, the REST API and also SQL API. Now we also have optimizations to make full refresh less expensive, right? So we can skip refreshes when we detect that there's no data changes, right? So if your reflection is based on all iceberg tables, we will track all the snapshot IDs that were used to materialize the reflection, and then on the next refresh, we'll compare the latest versus the ones that we tracked and basically diff it. If there's no actual data change, right, then we won't do a refresh. Now, another advanced optimization that we have is that reflections can actually wait on other reflections to refresh. So actually, you might not know that, like, when you materialize reflection, our planner can see that the job that is used to materialize reflection can actually be accelerated by another reflection, right? And so when you have this sort of chain of reflections, when you want to reflect the top level reflection, it would be better to wait for the bottom ones to refresh first before refreshing the top ones, right? So wait for your upstream dependencies first, right? So there's this concept of waiting or pending statuses on reflections. Okay, so that's what I have to talk about for reflection management. I just want to end with some tips on how to create reflections, right? So if you're following Dremio's semantic layer best practices, then you'll typically have your layered views, right? So you might have staging, business, and application. And so generally you want to create reflections on the top level shared views, right? Because these are the views that are accessed, by, for example, the end users, the applications, the dashboards. But also more importantly, these are the views that contain like hundreds of joins and, hundreds of scans, right? So you want to basically, again, pre-compute all that. Another tip is, don't just enable raw reflections directly on source tables, right? Because what you're really just doing there is just copying the data, which might not be providing much value. Instead, you really need to think about, whether you could partition or sort the data so that you optimize the file pruning, right, for your queries, right? That's what you should be thinking about there. Now, we also have a reflection recommender, right, which you can basically, feed your slow queries to, and then it'll give you recommendations, right? So it'll look at the query tree and basically say, oh, okay, I could recommend you to create a raw reflection on this view, or maybe it'll recommend, it'll see that, okay, what I can do is actually create a view off to the side, right, and then create a reflection on that view, and then have the planner, match that view's reflection into the same user query, right? And finally, and I showed you this already, is that if you need to troubleshoot what's going on with reflection matching, then you go to the acceleration profile, and you need to have verbose profile enabled.